Hi, I'm Dr. Viktoriia Sevostianova from IMDEA Materials Institute, and this is our second video of CARDIOBOOST Science Explained. In our previous video, we looked at how recreating the highly organized structure of heart tissue is one of the challenges in cardiac tissue engineering. In this video, we looked at one of the most promising avenues for meeting this challenge, liquid crystal display or LCD 3D printing. Sound interesting? Stay tuned. One powerful strategy that we have to engineer cardiac tissue is to create microscopic surface patterns. These tiny grooves and ridges act like physical roads for cells, guiding their shape and orientation. This phenomenon is called contact guidance. Cells sense the topography beneath them and naturally align along the pattern and direction. Fabricating these micropatterns, however, can be challenging. Traditionally, scientists use a technique called two-photon polymerization. While extremely precise, it's also slow, expensive, and often limited in the materials that can be used. So researchers began looking for faster and more accessible alternatives. And that's where LCD 3D printing comes in. LCD printing, also known as mask stereolithography or MSLA, is resin-based 3D printing technology. Instead of extruding melted plastic like filament 3D printers, LCD printers use ultraviolet light to solidify liquid resin layer by layer. The printer contains 4 key components: an LCD screen, a UV light source, a resin vat filled with photosensitive resin, and a movable build platform. Together, these components can fabricate highly detailed structure with microscale precision. But how exactly does this printing technique work? That's what we will look at in more details in our next video. I'm Dr. Viktoriia Sevostianova from IMDEA Materials Institute, and this has been CARDIOBOOST Science Explained. I'll see you in the next video.